This is Greg Troutwine with Marine Technology TV, and we're very pleased to be joined today by Professor Georgios Sylaios, the RTD Manager, ILIAD, and Bente Lilja Bye, the Innovation Manager of ILIAD, to discuss the ILIAD consortium, which was recently granted a 17 million euro from the EU to develop and launch a digital twin of the ocean. To start, can I just ask both of you to provide a brief professional background with insights on your responsibilities with ILIAD?
I'm Georgios Sylaios. I am a professor of oceanography in Democritus University of Thrace. It is a small university which is located in northern Greece, near the borders with Bulgaria and Turkey, facing the North Aegean Sea. And I teach oceanography, coastal engineering, and fluid mechanics. And I was the coordinator of another Horizon 2020 funded project called Odyssea, in which we try to develop over the Mediterranean Sea a system of numerical models and sensors to provide operational forecasts and data to multiple end users. And based on this experience, I participate now in the coordination scheme of ILIAD. With my role is the RTD Manager, meaning that I'm trying really to operate the various pilots that ILIAD will operate within the 3 years project that we have, the 3-year grant.
Hi, Craig. My name is Bente Lilja Bye. I come from Norway. I founded and lead a small research and consultancy company called BLB. The company is working a lot on usage of Earth observations, and both in terms of making data interoperable, that kind of thing, uptake in various applications, and such as climate change, mitigations, polar research, etc. Many different application areas for Earth observations. Also doing consultancy on data sharing and data management. So that's kind of the expertise now for the company BLB, and that will be also a ballpark of what we will contribute with. My background is actually theoretical astrophysics, but I say that I don't discriminate against any planet. So for the last couple of decades, I've focused my attention on planet Earth. So and the various aspects of that.
So for our viewers that are unaware of ILIAD, can you provide a brief background and an overview of the organization? A by the numbers look at ILIAD using the metrics of your choice, so we can understand the size, the shape, and the reach.
Yes, so the ILIAD project was an answer to the Green Deal call in the European Union's research program. It's 56 partners who answered this call. You rightfully said it was 17 million euros provided by or offered to us by the European Commission, but the total budget is actually 19 million euros. So it's a large effort to build the digital twin of the ocean. And we represent 18 countries. And of these, we have also representatives from Africa, from the Middle East, and of course, Europe. Among our partners, and we think this is the key to a successful digital twin of the ocean, we have industrial partners, we have the research institutions among us, and we also have actually end users already co-designing and co-developing this digital twin of the ocean. And we will build a marketplace that will function also after the end of the project. So this is not a well, it's a 3-year project, and we started just the 1st of February, and but we do already from the get-go plan to be sustainable, so we will be here even after the end of the project.
The only thing I wanted to add is that the project and the consortium covers, and the pilots we will develop within ILIAD cover all the European seas. So we cover and we have pilots and partners in the North Sea, the Baltic, the European side of the Atlantic. We have the Mediterranean and the Black Sea. And in all this area, we will develop a series of pilots to showcase the capacity of digital twin of the ocean.
So we talk about digitalization through everything that we do, again, covering the maritime, offshore, subsea, port and logistics industries. What exactly is a digital twin of the ocean and why is it important?
So digital twin is the capacity we currently have to benefit from Industry 4, the revolution that we currently, the era we currently live, which is the integration of low-cost sensors or myriad of sensors. Also, the capacity we have now to integrate this data in cloud systems and high-performance computers that can simulate this data and provide us with forecasts or give us a great understanding and insight of what happens within a system at every particular side of the system with high resolution and high accuracy. Also, we now have tools to analyze this data. These are called big data, and we analyze them with modern artificial intelligence tools like machine learning, deep learning, and other neural networks. Then we have the capacity to develop platforms and visualize all this data to the various users and the broad public. And finally, we have also in our capacity, we have now the social sensing, the social networks that also provide us information and data that we need really to exploit. And all this give us an understanding of how the system works. So we move from a physical asset, a physical system, to a digital system, utilizing all this wealth of data. But then, after the digitization of the system, we need really to go back to the physical environment and optimize it and to try really to adjust it and to be able to control it. So this is a continuous cycle that we have to do within a digital twin, going from the physical space to the digital space and going back and forth, utilizing the data coming from the system and controlling and adjusting according to the conditions that prevail at each particular time. So this is what the digital twin is the digital replication of a physical asset. But then if we place this system in the ocean environment, we have a digital twin of the ocean. So imagine now that we have various activities taking place at various parts of the ocean from private and public companies. And these people would really like to have high resolution, highly accurate marine metocean forecasts on the conditions that will prevail in the sea. We as oceanographers have the capacity now with the sensors, with the models, with all the data we collect and the satellites and all these systems to provide these data sets. But not only that, we need really to be able to adjust the systems they are using to control, to optimize their operation and their performance in order really to show that this is a unified system. This is something that can be demonstrated to the world as a new system that we will develop within the innovation of and the integration of all the units that we currently have in our disposal. So all these particular elements that I mentioned earlier, like the sensors, the models, the citizen science networks, or the particular AI techniques, are integrated within a digital twin context. And this is what we will do in ILIAD. We will go to particular areas where we have activities carried out by private or public companies. We will try really to optimize their performance through these tools. All this concept of digital twin of the ocean falls within the basic strategy and policy of the European Union, which is called blue growth and blue economy. So we really, through the digital twin, try really to upgrade the capacities of blue economy.
I know we're just starting it now, but what is a timeline for the project? When is it envisioned to be completed? And, in looking at the end users of this information, I imagine there are quite a few, but how do you see this information being used?
Well, first of all, as I said, the project to develop the digital twin of the ocean is a three-year project. However, we will not be interesting for partners unless we have a plan to continue. So the plan is to be something that we will offer also beyond this three-year project, to give a timeline here. Who the users are? Well, there are different types of users. We have tried to include different examples of application areas such as wind energy, aquaculture, harbor management, etc. So there are multiple application areas, and we want those users who are with us internally in ILIAD to help us create the tools and products and services that need. So it's co-design with the users.
As you know, we have at the moment, we have now, for example, a tendency to expand marine renewables in the ocean environment, the marine environment. So now when these companies invest in a specific area, they need to be sure that this area will continue to offer the wind or the wave resources as it does today in the future, in the medium and long-term future. So what we are doing here is that we analyze the specific conditions that prevail in the areas that these companies invest and locate to aid their operation and the functioning and the day-to-day management and their capacity really to take decisions based on the data that we will provide to them. In order to do that, we will use a series of low-cost systems, a constellation of sensors, which are really the high-cost systems, the well-known oceanographic instruments that we normally use, like current meters, wave buoys, gliders, AUVs, all these systems. But then we invest a lot in sensors, in the low-cost sensors, to integrate also this perspective and this aspect of ocean technology. So there is a group of partners in our consortium that will develop low-cost systems and will try to integrate all this data to the local servers and from there to the platform. And then we will try also to advance the knowledge in terms of modeling. We have a series of coupled and high resolution and highly accurate models. And then we want to make a jump between the geophysical fluid dynamics towards the computational fluid dynamics to incorporate also the performance of the various turbines or the various elements of each facility. At the end, we also need to integrate the data coming from satellites, data coming from the social media, the social networks, the citizen science, and all this will give us very big data sets that we will analyze with new tools like AI and machine learning tools. The ultimate scope is, of course, as I say, to be able to go back and optimize the systems and their performance. So in the case of wave energy converters, we have three areas that we will focus our attention in: Gibraltar, in the Mediterranean Sea, in the Baltic, and in the North Sea. And then we have also wind farms in our consortium, wind farm operators. We have harbor managers and harbor operators in Varna, in Black Sea, and also in Tallinn, in Estonia. We have fishery operators, people that collect data on board of fishing vessels. And all this give us the capacity really to understand and to create test cases and user cases based on the demand of users on data.
So in summary, you could say that the users are both of the digital twin of the ocean is both those data providers, those who are running instruments and sensors. We have citizen science as well as a component, and those who are offering then services based on all this. So, and also policymakers. One of the challenges for policymakers is to have the proper facts and knowledge to create their or update their policies. And so they are also an important user group.
In terms of the diversity of the pilots, we have what we call environmental ecological pilots, where we try really to digitize and simulate environmental processes like the occurrence and the concentration of microplastics on the ocean. We have a company that builds microplastic sensors, and we will miniaturize and integrate the sensor in various vehicles like gliders or AUVs, so that we are able to collect data on microplastics over the ocean. Then we have ecosystemic pilots, and we have the hybrid pilots, what we call hybrid because they are not fully engineered as the wind and wave energy pilots. We have the oil spill pilots, where we will simulate the dispersion of oil spills based on satellite data, and then we will try to integrate the authorities and the policymakers in the mitigation, and we will try to model the effects of the mitigation, the actions and the response to the oil spill in a single model, so that we have really developed at the end of this period, of the 3-year period, we have a system that will act as a system of systems and will be able to integrate all these pilots.
So tell me about, obviously it's a 3-year program. Obviously to make it valuable for your stakeholders, it's going to go much further than 3 years. So what is the plan? Will this digital twin be available globally freely, or is this going to serve as the centerpiece of a business model?
Well, of course, there will be a business model, because you need a business model to be keeping on running something, right? Whether or not is a commercial or a public service that you provide. In the European Union, there's an open data sharing, open science policy, and we will adhere to that the best we can. But as you know, there are certain things that are either sensitive in the sense that you need to watch out for security issues, etc. And there are also the commercial interests. So somebody needs to pay no matter what you do. So there will be commercial products as well that will not be open. But we will have a marketplace. So you could say that it will be an open marketplace available for everybody around the globe. It will then depend on what type of product or service or how you want to use this marketplace. You can use it as a provider of a service or data, or you can use it as a customer or somebody looking for a tool or a service that you need to solve a problem or challenge you have. But it doesn't help you if you cannot use it. So we have this ILIAD Academy where we are training, we are offering different types of trainings to the users. Also among the different actors already developing together the ILIAD, but also we will be offering this for users, external users, when that time comes. So it will be like an ILIAD Academy. So like Georgios said, it's interesting to actually gradually develop new knowledge in order to make sure that ILIAD is still there, the digital twin remains there. You need to constantly develop new competence, etc. And this will also, this ILIAD Academy will also support those processes.
What do you count as the primary tools in your toolkit to get this job done?
Yeah, I think the primary tool that we need to advance here is the low-cost sensors, is the systems that will allow us to collect a lot of data from multiple points constantly and continuously, and this will, integrated within the other systems, will give us a better knowledge of what happens in the marine environment, in the limited space that we have the various activities carried out. The other challenge is, of course, how to transfer all this data to a server, which is land-based or in the cloud. So what are the speeds and the volumes and the capacities we have to transfer these big data sets to a cloud system, how we process them. This is what the different partners will do, and to be able to provide services that are real-time or near real-time. So for us, it's extremely important to be able to push a button and receive data in real-time mode, and to be able to process them as soon as possible, and to provide the services and the solutions to the users to reach the decisions based on this data. So this is the main challenges for me are those.
I will add a more softer, maybe, perspective, and that's in terms of the toolbox that we use for innovation. I think that the methodology that we will apply with agile development is a major component of the building of the digital twin of the ocean. We will start very fast to get a minimum viable product, and then we will iterate to gradually build on that before we have then a service or a new data product, etc., that will be perfect for the users. So we will go through very quickly the methodologies to very quickly build this minimum viable product, and then gradually build on to you get, I guess it's an endless process, but this methodology, this innovation methodology, if you like, I think is a major tool that we have in our toolbox.
In looking at this project in overview, what do you see as the greatest challenge to overcome in creating this digital twin of the ocean efficiently, effectively?
From my point of view, I think is the collaboration with end users. It's extremely important to understand, to give them a clear message what the digital twin can do to perform, to their performance and to their optimization and improvement of the system. So it's very crucial for us to be in a position really to deploy our systems, run our models for a specific purpose, which is defined by the user, so that without the collaboration of the users, this project will fail. I think that it's something that we need to take into account. Some of the users, as Bente very well said, are already in our consortium, and they will help us in the implementation of these pilots. But for me as an operational manager, looking at the oceanographic point of view, I think that the collaboration with the users, the capacity to reach their systems and understand the problems on a day-to-day basis is extremely important.
Yeah, I agree that this engagement with the users will be one of the biggest challenges, and a part of that, to take on a more technical hat in this time, is generally interoperability. So it needs to be interoperable on so many levels, not only sharing the data, but it needs to be interoperable with, for instance, existing management systems that they have. You need to develop something that is interoperable with what they already have for fast uptake of the innovations. So yeah, the interactions with the end users and interoperability on the more technical side, I think those are if we should say one thing, I think that's the key challenge.